Hello friends, so welcome in the new video. This is the third part of the interrupt, and in today's video I will explain you the concept of interrupt nesting and how STM32 handles the preemption. So to understand this, one image is there on your screen. You can see left side person is doing some work, person is cooking some food, and in right side you can see a fire alarm is there. So interrupt nesting means one interrupt is currently being executed, and at the same time if another interrupt comes, then how microcontroller will handle it, right? So to understand this concept, just assume that you are doing this type of activity in kitchen, you are cooking some food, and if some fire alarm generated, right? So obviously fire alarm should have higher priority. So just understand that this fire alarm is an interrupt 2 and interrupt 2 is having higher priority. So even you are currently executing interrupt 1, even you are doing some activity, but as the higher priority interrupt generated, you have to deal with the higher priority interrupt first. Then and then you can check the lower priority. Otherwise, otherwise you know what happened, what could be the result, right? So as the same with the same example, you can consider this higher priority interrupt as a fire alarm and lower priority interrupt as a cooking of food. So while you're cooking a food, if fire alarm generated, fire alarm's priority should be higher. Your microcontroller should execute the higher priority interrupt first. It should complete that higher priority interrupt, and then it should start the lower priority interrupt from this place where it was executed, or it means status should be saved first, and then after the returning back, it will start executing from that particular space only, right? So this is what the concept of interrupt nesting and the preemption. So the interrupt nesting allow higher priority interrupt to interrupt lower priority ones while they are being served, right? And this is controlled by NVIC. So NVIC, you know that, right? In last video we have set the priority using this table, and higher number means lower priority, right? 0 means highest priority, 15 means lowest priority. So we have already discussed this, and our goal is to understand how higher priority interrupts can interrupt a lower priority one. And let us understand with the circuit, with the actual code. So this was the circuit, right? In our previous two videos I have explained you. So here basically we have used two interrupt, one interrupt with PA9. So this switch is actually, you can consider as a external interrupt. So when I press the switch and release it, so interrupt will generated on this pin. And we have seen that we have wrote this logic for callback function. So whenever interrupt is there on pin number 9, it should toggle the pin number 10's LED, and it should display this message on UART. This is from pin number 9, and same way for pin number 14 also, right? This is from pin 12. So pin 12 is basically LED connected with this. So that's why I wrote some confusion is there, right? Here this is pin number 9 and this is pin number 14. Sorry, yes, pin number 14, right? So let us simply generate the hex file and check. So right now normal task is going on. Now let us generate the interrupt on pin number 9, and here you can see the message is pin number 9, and this LED you can see it is now on. It's basically toggle the LED. Same way let us generate interrupt on PB14, and this is from pin number 14, right? Same again. And we have also seen that the priority of PB14 is higher because lower number is there, right? So if both interrupts will generate simultaneously, first it will serve this interrupt, right? This is also we have discussed. Now in today's video, because we are discussing the nesting, interrupt nesting, so let us add some delay, because right now whenever interrupt generates, it quickly executes it. but let us generate some delay so we can have proper understanding of interrupt nesting and preemption, right? So for that, let us add some delay, and here we will use user defined delay, right? We will not use HL delay because with interrupt it will not work. Okay, we will discuss this later on, but right now just assume that we cannot use that HL delay, right? And we will simply, after some time, we will display this message. This is from pin number 9 and, okay. So it will simply tell us that now interrupt is being executed, it is complete, right? And let us write some large number. Okay, same way here also we will do the same thing. We are simply adding delay and we are simply adding message, right? So from the message we can have understanding that okay, now interrupt execution is finished, interrupt service routine executed this there that part completely, and now it returned back to original state, right? And now this is user defined delay, so we have to define this function, right? So let us define void user delay volatile, sorry, now as an argument, and assign integer 32, and let us take count as an argument, and simply use while loop or for loop, count minus minus, right? So this is basically will decrement the count by 1 up to 0. So it will generate some delay, right? So now X file is generated. Now let us execute this once again. Now let us generate first this PA9 interrupt. So this is from pin 9. Now currently interrupt is executed. Now this is end. Again, now we are generating interrupt on PB14. Yeah, but currently it is executed continuously, now ended, right? Same way, start, end. Same way, start and end. Now I will show you the demonstration of the interrupt preemption, how microcontroller handle this condition. So we will generate another interrupt while one another interrupt is currently being executed, right? So let us say this is the task 1, okay, cooking a food, and this is fire alarm, and obviously you know that the priority of this is higher. So let us start this interrupt, and in between generate the interrupt. So you can see even P9 was executing, it is currently in execution state. It hold this interrupt, it execute the higher priority interrupt first, it finish the higher priority interrupt, and then again it will start executing this from that particular space only, and then it will finish the same. Okay, so the working is like currently is executing PA9, then suddenly it realized that PA14 interrupt is there, so it jumped from PA9 to PA14, complete the PA14 interrupt, and then it come back to the exactly same place where it was the execution was transferred, and again it will finish the lower priority interrupt, right? Let us do it again. PA9, PA14, PA14 and PA9 and. Now let us do this in reverse. But you can see now as PA14's priority is higher, so first it will complete the execution of PA14, and then it will start PA9, right? Let us do it again. Right, this is because PA14's priority is higher, and let us execute again with lower and then higher. You can see PA9 start, PA14 start, PA14 end, and PA9 end. So this is what the interrupts nesting and how microcontroller handle the preemption. In future video, I will come up with more concepts related to the interrupts with various hardware like UART, SPI, I2C. So this is what for the today's video. If you like my work, then please like my video, subscribe channel, share it with your friends. Thank you very much.